This example comes out of section 7.2, Transformations of Exponential Functions. So as an introduction to this, we're basically just going to graph one simple exponential function, y equals 2 to the x. We do a rough sketch of it. We've seen it before. It's a growth function. Goes to the point 0, 1. Has an asymptote at y equals 0. And we could label another point here like 2, 4, or some other point on that graph. We're going to initially be asked to graph things like y equals 2 to the x plus 3, or y equals 2 to the x minus 1. Even if you were here for the very first lesson of the year, hopefully you would look at this and say that I expect that to be a vertical translation of 3 units up for the first one. So I would take this graph and go 1, 2, 3 units up. My asymptote is now at y equals 3. Take the points and move them each 3 units up. I'd have the point 0, 4 and 2, 7. So I have a curve that looks the same shape as the one I had above, but it has been moved 3 units up. So by the same kind of logic, this one looks like it should be a vertical translation of 1 unit down. So if I sketch that very quickly, very roughly, the asymptote comes down here to y equals negative 1. The y-intercept now becomes 0, 0. And that point that was at 2, 4 is now at 2, 3, so somewhere over here. And I have a curve again, once again, the same characteristic shape, same shape as the ones above, but in a new location. It's been moved down 1 unit. Same type of logic as that. If I started off with, let's say, another different exponential function like y equals 1/3 to the x, just so we can see that these things don't have to be a certain base. This is an exponential decay function. It's decreasing as I go to the right. It still has the asymptote of 0. Has the y-intercept of 0, 1, but if I picked a point, I might get like negative 2, 9 as a point on that graph. This time we're going to be asked to do something like this. Leave the base the same, change this to x minus 2, or change the exponent to x plus 3. If you saw the ones above as vertical translations, hopefully you'll see the ones here as horizontal translations. I expect this one, changing x to x minus 2 in any equation, I expect it to move it 2 to the right. And that's exactly what we'll end up drawing here, is drawing this same curve. The asymptote doesn't change, because if you move a horizontal line to the right, it still is the same horizontal line. The point that was at 0, 1 is now at 2, 1. The point that was at negative 2, 9 is now at 0, 9. And you have, again, the same shape of a curve, but the whole location, the whole thing has been shifted to the right, translate to the right 2 units. This bottom one, again, by elimination, makes sense that it should be horizontal translation of 2 to the left, and it is. So if I draw it, I have myself a asymptote still at y equals 0. The point that was at 0, 1 is now at negative 3. Whoops, I wrote 2 instead. 3 to the left. 1, 2, 3. So negative 3, 1. And negative 5, 9. So somewhere way up here. Negative 5, 9. Negative 3, 1. Same shape curve as I had before. Approaches the same asymptote as I had before. Often they like to ask domain and range questions about these. You'll notice, I hope, that all of these at the bottom here have a domain of x as an element of all real numbers. In fact, every graph on this whole page has a domain of that. The range of these bottom 3 is that y has to be greater than 0. But these upper ones are not all the same. The first one is y is greater than 0, but the next one is y is greater than 3, and the last one, the third one of those, is y is greater than negative 1. Moving a graph up or down, when it's an exponential graph, does change its range as it changes the location of that asymptote.